Hello everyone, my name is Vaibhav Anil Vora and today I am going to present a project on design of Altera Neos 2 instruction subset architecture. I have done this project under the guidance of Professor Changchu. First and foremost, I would like to thank our Professor Changchu for his valuable guidance and support throughout the semester and helping us throughout the semester with the subject. Moving to the introduction, Neos 2 is a soft processor. It is incorporated in a system implemented on an FPGA design. Neos 2 allows easy interfacing of new peripheral blocks to the existing software that we already have. This comes in very handy. It has a capacity that can modify the hardware which is inbuilt in the FPGA. This feature is useful for delivering high performance in microprocessors. Neos 2 is based on the RISC architecture as compared to the CISC architecture. This diagram shows the architecture of the Neos 2. It basically has 5 different stages. The first stage is the instruction fetch stage. The second stage is known as the instruction decode stage. The third stage is the execute stage. The fourth stage is the memory access stage. And last but not the least is the write back stage. In the instruction fetch stage, the content of the program counter is used to access the memory and fetch the next instruction to be executed. In the instruction decode stage, the 32-bit instruction is decoded and the required operands are retrieved from the general purpose registers or special function registers. In the execution stage, all the instructions are executed in this stage. For memory instructions, base address and offset address are added for obtaining effective address in this stage. Now moving on to the memory access stage. In this stage, for load and store instruction, memory needs to be accessed. Effective address is applied to the data memory and the read or while is performed in accordance with the instruction type. This stage is slower than compared to other stages. And last but not the least, when we come to the write back stage, in this stage, the results of the calculation from the execute stage or the memory load from the memory access stage are updated in the register. These are the 5 main stages as described previously. This uses a pipeline structure. This pipeline structure is used for providing optimum performance. Optimum performance is achieved using this pipelining. Pipelining allows simultaneous execution of a number of different instructions. This type of pipeline structure improves the overall efficiency of the processor and hence it delivers better performance. Moving on, we also have certain type of hazards that are resulted due to this type of architecture. The 2 main types of hazards described are number 1, data hazard and number 2, control hazard. Data hazard is when current instruction requires the result of a preceding instruction. Now, the measures to avoid this data hazard are: first, stall the cycles have to be introduced where there is data dependency. Whereas, control hazard is when fetch cannot continue because it does not know the outcome of the previous branch. One of the key measures to overcome control hazard can be sequence of instructions have to be rearranged. Moving on to the results. Here we see the waveform for the add and multiplication instruction. The opcode for the multiply is 3A. The value 6 is stored in register A1 and a value 3 is stored in register B1. We multiply 6 and 3 and the output is stored in the ALU. The opcode for addition is 3A and registers A1 and B1 are added and the value, that is 0, is obtained. The next is, here we see, is the waveform for the load instruction. In load operation, data value present in the memory is loaded in the specified register. Here we see that 60 is stored in register B and hence we obtain the following result. Next we move is the waveform for the branch instruction. Branch instruction transfers the execution of the program to a different memory location. It is an I-type instruction as the 16-bit immediate value specifies the offset address. There are two types of branch. First is the conditional branch and the other is the unconditional branch. In conditional branch, branching occurs only if the condition is satisfied. In unconditional branch, there is no such requirement which needs to be completed before branching. This example here shows the waveform for the branch instruction used in the program. Last but not the least, this slide shows the output for the final answer, that is 580, which is stored in the register. And here we see that 580 is stored in the memory location 100. Now we move on to the conclusion. The conclusion is as follows. The 32-bit Nios 2 processor was designed and implemented using Altera Cortex. This processor has the capacity of handling various R-type, J-type and I-type of instructions. All instructions are executed in a single clock cycle. Stall cycles were also inserted to avoid the hazards that were discussed in the previous slides. Most importantly, this project has provided me a vital chance to acquire hands-on knowledge on the Nios 2 5-stage pipeline processor. One of the key things is the future work that can be used for the future development of this processor, and it can be implemented in the following ways. First, implementation of data forwarding and bypassing for pipeline hazard detection. Second, implementing pipelining with more than 5 stages is something that we can always look forward in the future. And lastly, superscale processors that execute multiple instructions in only one clock cycle is something to always look forward as a future work. These are the references that I have used and taken help of. Thank you.